Okay, so I'm live here, 52 weeks of Swift. I'm on protocols this week, and I'm gonna go to a Swift documentation page here, bring it up, Xcode, and so I'm launching Xcode real quick to get this thing working. And I'm going to start a playground. So we'll say file, new playground. There we go. Okay, and I'll just say blank. We'll call this protocols. So we got protocols cooking. And I guess the easy way to do this is to just share again my screen here for this. Share the screen, protocols. There we go, and got it. Okay, so we got Swift cooking here. Looks pretty big. All right. So in order to get into this, I'm going to continue to use the official documentation because it's pretty good. So I'm going to dive into protocols and just pull up the docs here real quick. And where's the Swift documentation? Let's say Swift documentation. There we go. Got it. Standard library. Protocols. Oh, we changed the documentation a little bit. I think they did. Let me see here. Swift language. Language guide. Protocols. Okay. So the idea with a protocol is that a protocol is another kind of style here that does a lot of fancy stuff in Swift. It is a blueprint of methods and properties and all kinds of stuff like that. And so the reason you would use this is to make something conform to a protocol. So the style, if I was going to paste this into a playground here, would be this. Oops, wrong cut and paste. It would be this. Here's a protocol, and so it puts a definition right there. Now, if I wanted to do custom state that adopts a protocol, I could do this. And if I wanted to do, if a class has a superclass, list the superclass name, you do this. Okay, makes sense. A protocol can require any conforming type to provide an instance property or type value. The protocol doesn't specify whether the property should be stored or computed property. If a protocol requires a property to be gettable and settable, that property requirement can't be fulfilled by constant stored property or read-only computed property. And so property requirements always are declared as variable properties. So let's go ahead and take a look at this. Let's put this in. There we go. Always prefix the type property with static. And so that looks like it works. And we could say another protocol. Let's go ahead and put that on there. And then here's an example of a protocol with a single instance property requirements. Looks good. Fully named protocol requires a conforming type to provide a fully qualified name. And so here we go. If we run this, we say person is fully named, so it's going to use that protocol. Var full name string, let Johnny Johnny Appleseed, and John dot full name is John Appleseed. So this example is a structure called person, and it adopts the fully named protocol. If each instance of the person has a single stored property called full name, which is a type string, this matches the single requirement of the fully named protocol. Here's a more complex class which adopts and conforms to the fully named. Okay, let's go ahead and try this out. And let's do this. So we have class starship we use as fully named. So again, the fully named is this, the var prefix string, var name string, init. And so this is INC 1701 equals Starship Enterprise. There we go. And if I uncomment this and I run this, we can see that expected type after is interesting. I don't know exactly what's going on there, but we'll keep going. Method requirements, as with property requirements, you can always type prefix type method with a static. And so if I did some protocol here, up here, I said static function, some type method. The following example is a protocol with a single instance method. So let's just go down here. Let's just go down further and run this. So this is a protocol random number generator, func random double. So the random number generator requires any conforming type to have an instance of a method called random, which would return a double value when it's called. And so if we want to use that, here's actually the example. And we'll say use protocol. And what we can do is see what it does. So class linear congruental generator, random number generator, var last random. So these are all doubles, right? So it's basically making sure it returns a double. Here's a random, so it's got to have a random in there, and then we return back. So let's go ahead and run this. Here's a random number, 03. Here's another one. Now, if I change this to random 1, and I change that to random 1, I'm assuming this will blow up. And it says, there we go, does not conform to the protocol. So that is a neat little tool here to basically, if you have a specific thing you're trying to enforce, you enforce them with protocols. Mutating method requirements, it's sometimes necessary for a method to mutate the instance it belongs to, and you can also define a protocol method that's intended to mutate instances. Here we go, protocol toggleable. We go down here, and then if we turn this on, we can go ahead and say that. And if we run this, we say light switch toggle. So go here. Let's go ahead and take these out, comment them out, and run it. And I guess I can say light switch toggle on off switch, var light switch. light switch equal or lightbirds dot on equal true. Does that work? I actually don't know the conditionals, how they work in Swift, but I guess if I just print it, maybe that'll show me. What does that do? So if I run it again, so it's off. Yeah, so I would need to play around. There you go. You print it, and I guess print must have some smarts where it knows how to print things. So if I don't do the toggle, let's do that. We can see that it's actually off. But then if I do the toggle, see it's on. Cool. Okay, so you can also do protocols for class implementations of protocol initializers, protocols as types. So basically, protocols don't implement any functionality. They're just a way of making sure that things are conforming to a certain set of rules. And you can use delegation. You can add its conformance with an extension. And so it's pretty amazing, actually, if I look through all the different things you can do with protocols and how to get them running. So that's enough for me, at least, what I was wanting to get out of this. I think I know enough about protocols in Swift, and it's an interesting tool, and I'll definitely take a look at it as I keep learning the language. Next week, we're going to cover generics, which are flexible, reusable functions and types that work with any objects. All right, talk to you next week.